At the end of class, if you have any questions about the PSAT, now, you know you can't give me the exact question, but if you can say, Miss Wilby, can you show me something like, and give me something similar, I can help you with it. All right, so here we go. There's a couple different ways to do SAT problems, and I always do them the easiest way. That is my method of choice. So for number one, I wouldn't work at all, because the answer's down here somewhere, isn't it? So I'm going to look at these. Can I do 240 minus any of these numbers and get 80? No. So that can't be it. Not going to try it. So if I did 200 minus 120, that does give me 80. What's 120 over 200? Does that reduce to 3/5? Boom, I'm done. B. Or you could do it the long way. All right, so the long way would have us solving this for B. So move this over here and move the 80 to the other side. And then we would substitute. We would use substitution, which we just studied. Substitution as a method for solving a system. And then you would cross multiply and solve. And if we cross multiply, we get 3a equals 5a minus 400. So negative 2a equals 400. Negative 400, excuse me. So A is B. A is B.
Is B C? Or is it only A B?
Only A is B.
Okay.
Yeah. Yes, sir.
You looked at the bottom and you're like, well, can I subtract from these numbers to get 80?
Yeah.
And you were so confident that they would have both the variables in one of the answers. How do you know that there would be both variables in
Or that's true. Or I could go 240 minus what is 80? Would that work here? 200 minus what is 80? Would that work here? Okay, this one. You could solve for m and then substitute in, but you shouldn't. Because do you see this is 6m and this is 3m. So if I double this, don't I now have 6m?
Equals 22.
So 6m equals 22, and that's what I plug in. X minus 22 equals 27. Answer 49. Done.
Got that one. Yeah.
Wait.
So don't do more work than you have to. Like on this one. Do you see if I move the x over, I get negative 5 equals y minus x. So what do I plug in for y minus x? Negative 5. And negative 5 cubed is 125. Negative 125.
Well,
You got it.
What?
Okay, questions? All right, all these questions came from when I used to teach the SAT class. I stole them off one of my old quizzes. Yes?
I should have asked this when you said questions. But if I ask you a question, how are we supposed to know if I asked you a real question or a similar question?
She wouldn't. It's called the honors.
I wouldn't, but I told you not to give me a real one, so I'm assuming you're not. All right, so here we go, 10, 11, 12 on our homework. Let's take a look. Okay, we can tell it's been shifted up 2, so this was the easy part, the up 2. Very good. Now, how do I know the base is 2? Well, the way I figure it out is I go to where I found the spot that's just 1 up, and then if I go 1 over, this is my base raised to the first power. And you see I get out a 2. So what number to the first power gives me 2?
That's exactly what
2. 2 to the first power is 2. All right, so here, I go to where I find 1 up. And I go 1 over, up 2. Now, how many people got this answer? Raise your hand.
I did.
Let me check.
I got the.
About 4. How many people? 5. How many people got this answer?
That's what I did.
I got the first
About
one.
4.
The first one.
5. Okay, so we're 6 and 5. And then 10 of you didn't get an answer. Okay, well, all of you that got this answer
Are wrong.
are right. And all of you that got this answer are also correct. Yes, you are. Because, okay, some of you know this rule already, and some of you are about to learn it. When we multiply like bases, so if we had x to the second times x to the third, we add the exponents, right? Do you see if I took this problem right here, 2 to the understood first times 2 to the x, could I write it as 2 to the x plus 1?
Yes.
Yes. So do you see that this is equivalent to this?
Now I do.
Yes. So we could either write this as a shift left 1 or as a vertical stretch by a factor of 2. This is only going to work if the vertical stretch is the same as the base. Okay? We can't have a 3 here and a 2 here in this work. It doesn't work then. All right? Interesting. Okay, now this one, shifted down 4, we can easily see. Here's up 1, so it hadn't been shifted left or right any. But do you see if I go over 1, this time I go up 1, 2, 3. So my base is 3. Those of you that had questions about how to figure out the base, are you okay now?
Yes.
All right, let's keep moving.
Yes.
Okay, number 1, shift up 1. My base is 1/4, so if I go left 1, 1/4 to the negative 1 flips it, and I get 4. 1/4 to 0 is 1. 1/4 to the first is 1/4. Hopefully you drew a better curve in than I did using the Moby. You have a domain of negative infinity to positive infinity, range of 1 to infinity, and asymptote of y equals 1. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches 1. Any questions about number 13? All right, I see no questions. Number 14, drop down the asymptote by 1. Shift right 2. Now, does everybody know that 0.5 is the same as 1/2?
Yes, I do.
Excellent. So we know it's going to be decreasing from left to right. It's a decay. So if we go left 1, 1/2 to the negative 1 is 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2. Draw in our decreasing curve here. Yes, sir.
It looks like, so we were supposed to do like the domain range for and everything for what question?
13 through 20.
I did 10 through 13.
Okay. Negative infinity to positive infinity, range is negative 1 to infinity. Y equals negative 1 is your asymptote. Are you putting y equals and not just negative 1? Because it's a line. It's not just a value. It's a line. Okay. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches negative 1. Yes, Andrew?
You know how you said that it has to be y equals negative 1? Could you put asymptote at negative 1?
Nope. You have to put the equation for the line because the asymptote is a line.
Okay.
All right, now this 3 out in the front. It is going to be a vertical stretch by a factor of 3, which triples our y's. And also, do you remember that if we don't have a vertical shift and we have this multiple out in front, that is our y-intercept, isn't it? See the 3? See the 3? Y-intercept.
Whoa.
All right, so if I did the 1/3 to the negative 1, it's 3, but there's the 3 that triples it, so that points at 9. 1/3 to the 0 is 1, but the 3 triples it, so it's 3. 1/3 to the first is a third, but when we triple 1/3, what do we get? 1. We have our points. Draw in our decreasing exponential curve, and we get this domain, range, and end behavior. And okay, this was shifted right 1. That's not right. That's left. Left 1. And doubled. Now, does anybody notice if we shift it left 1 and double it? 2 to the first. 1/2 to the x plus 1. Could I think of 2 as this to the negative 1? And 1/2 to the x plus 1? Could I think of 2 to the first as 1/2 to the negative 1?
If you wanted to.
Yeah? And now I have like bases, so what could I do with the exponents? Add them, and negative 1 plus x plus positive 1 is just x. Does this look like 1/2 to the x?
Yes, it does.
Yes, it does. Yes, sir?
Why would you do that if you, never mind.
I'm just showing you that they're the same. That's all I'm doing. All right, take a look at this. If it had no shift to it, our asymptote would be at 7, right? But it was shifted down 4. So what's 7 minus 4?
Down
3. The y-intercept is 3.
I knew that.
Oh.
And the asymptote is y equals negative 4.
I got that.
Oh,
So keep in mind, when it's in this form, when there's nothing added or subtracted to the end, a is your y-intercept. But if it's shifted, then you have to take that into effect. So it would be 7, but it was shifted down 4, so it's at 3. Okay, the domain for 18 through 20 is this. The end behavior on the left side is this. The end behavior on the right side changes, and the range changes, and the asymptote changes. But I wrote those changes over here. So take a look at 18, 19, 20.
Got those right.
And then the last 3. Okay, last period, I had written them like this, but last period somebody asked me if they could write them like this, 3 to the negative x. Well, isn't 3 to the negative x the same as 1/3 to the positive x? Sure, you could go either way. Any questions about 21, 22, or 23? Okay. I think most of us are really good about doing this in here, but when we go over homework every day, I can see most of you doing it. Correcting your homework, looking for the ones you missed. So if any of us are surprised by what we make on our test or quizzes, like we really thought we understood everything, and then we might make like a low B, or we might make a C, or that kind of thing. Let's make sure that your homework, you're using your homework every day as a guide to let you know. If you're correcting more than 2 or 3, then maybe you didn't know it as well as you wanted to. And it sounds really easy when I go over it, doesn't it?
Oh, extremes.
It does. That's because I've been doing this for a long time.
Multiple years.
Longer than you were born, yeah.
Awesome.
Yeah. I've been teaching since 96. Anybody?
That's 2 years before I was born.
Yeah. Yes.
Never mind, actually. That's
Don't be mean.
appropriate
Yes.
for school.
Don't be mean. All right. So here we go. This one, we haven't had one like this. What does a negative out in front do? Reflects it over the x. And when we reflect it over the x, all that does is change our y values to the opposite. So this positive 1 becomes negative 1. This positive 2 becomes negative 2. This positive 1/2 becomes negative 1/2. So when a negative is out in front, it is a reflection over the x-axis, and that's what's going to happen. Okay, questions? All right. Today you have a learning task that you can work in groups to do. I'm going to pass that out now, and then behind that I'm going to come back with a half sheet that is your homework. The half sheet is your homework. And because I know Ryan's listening to this video and he's going to check the website for his homework, I'm going to, especially today, post that for you.
So,